So in module 2 you have two types of connection. One is welded connection and another one is bolted connection. First you have to understand where the connections are used and what is the purpose of connection. You can understand by this figure. See, the connections are the parts where two members are being joined. It might be beam and column, it might be struts. So in normal framed structures you will be having this beam and column, but in steel you cannot make it monolithically. You have to take two separate members and you have to connect. This is a column and this is beam. So in a beam column you will be having a web angle. So this connection and this component is known as web angle. So what do you mean by angle? Angle is L section. So in terms of steel, angle is known as L section. So an L section is provided here and it is being connected by the bolt. So this is one type of connection. So you have different types of name for connections in steel. Wherever they are using, for what application they are using, the name differs. Here you can see this kind of an architectural appearance. So this you can see in monumental structure. At the end of the column you will be having this kind of structure. So these are all known as brackets. This connection is known as brackets, and for what purpose they are providing this is not only for aesthetic view or for architectural purpose. This is a connection. You can see there is a member behind that. There is an member, bracket member behind this. So this component is only the architectural view, but component is welded with this, and this is provided for bracing. So if you need to connect between beam and column, and if you want to connect with that, brackets will be provided. So this kind of bracket, this is also a type of connection. This is welded connection, and this is known as gusset plate. All the terms are technical. So you should know the technical term for that what you are designing. So this gusset plate, what do you mean by gusset plate is, see, this is a truss, and in this truss this is constructed in a bridge. If in a bridge number of members are aligning at a single point, all the members have to be connected by a single component, so that the connection will act as a single member. So for making that, component is being added which is known as gusset plate. So this is a plate, and by this plate all the members are riveted, or it might be bolted. So here this is riveted. This is known as the component called gusset plate, and you can see this is a bracket. This is another type of bracket which I have shown here. This is only structural bracket, where you can see in workshops. In workshops you will be not seeing this kind of aesthetic. Simple bracket will be bracket plate. This will be a plate and which will be welded with beam and column. Okay, in terms of any house or for any monumental structure or palace, this bracket is being converted into this shape. Okay, so this is one of the connection. How these two components are connected? By using bolt. You can see this bolt is being driven here, and bottom you have the bracket for making the stiffeners. So they have given a term called stiffeners. So this stiffens the junction. Okay, now you have another component. This is known as clip angle. If you are joining the beam and column, if it is connected here, so what is the type of connection? Web angle connection. So this is web of any portion. So what kind of section is this? This is an I section. In an I section, if the web, so this is web and top portion is known as flange. So this is flange and this is web. If the beam and column is connected with the web and the flange portion of the column, then it is known as web angle connection. If the top, you can see that this is the flange of the beam and this is the flange of the column. If two flanges are being connected in beam and column, the top portion is known as cleat angle. So what do you mean by that? Cleat. So this is a technical term. And if the same is being connected at the bottom, you have to say it as what? Seat angle. In a beam, if bottom is being connected, then it should be known as what? Seat angle. Why? Because in this bottom it is being seated. The beam is being seated and hence it is known as seat angle connection. And if it is provided in top, it should be called as cleat angle. So why they call it as angle? They have provided L section. This is L section, no? The cross section is L. So this is known as the cleat angle section. L section are called angles. Okay. Now you got some idea about connection. Why these connections are used? The assemblage of different members such as beam and column and tension member. See, this is known as beam and this is column, and these are all tension members. What do you mean by tension members? These are all struts. In a truss you will be having different types of connection. So all the connection, it might be compressed or it might be tensioned. So it might be a tensioned component. So these tension members which are fastened, the connections are technically known as fasteners. So in your code book they might indicate in this terminology. Connections are fasteners or fastened to one another, usually at the member ends. So the connection generally at the member ends, but in between also connection is available. This I will explain further. Okay. The connection between different members in steel framework not only facilitate flow of forces and moment. Why you are providing these two? Connection is, see, what you are studying in this module is this component only. You are neither studying this beam, neither studying this column. You are only concentrated in this connection. What is this bracket? What is this web angle? These connections. Whatever you are doing, how you are connecting. Either you are connecting by rivets. So these are all the example for rivets. This is the example for bolt. Bolt you will be having a nut and a component. So by nut you can try it and you will be having nut and bolt. And third type of connection is weld. Nowadays they are not using rivets. So these are all riveted connection. If you want to connect two members, earlier in major of the railways they use the rivets. How they are making the rivets is they will heat the rivet. So it will be similar to a bolt where you will be not having the threads. So in the bolt and nut you will be having the threads, yes or no? So in rivets you will be not having any threads, you will be only having the strands. It will be heated to the higher temperature and it will be hammered. So with heat and then you have to do that. And slowly the rivet component is over. Now whatever structure is being built, it either is welded or it is being bolted. Rivet is being removed. When I am studying the BE, three type of connection I studied: rivet, bolt and weld. But now due to workmanship, even workers are not working as hard as earlier. Before a decade, the worker were very much harder than today. So before 200-300 years, the pyramid was built, Taj Mahal was built, all the components are marble, no machines are available, all stones are being carried by humans and by the wheel and the cart. The power is human only human power and mechanical power. Right now we are having hydraulic power is being used for JCB and electrical power they are using for lift. So manpower is being used there the workers are very hard to work, but slowly the technology also changes. Why you have to need to heat? Why the rivets has to be heated and it has to be hammered and it cools. After it cooling, it will become a normal member. If you remove the rivet, you cannot install it again. But if you are using the bolt, you can tie it and you can unremove it. You can use another time, yes or no? The bolt and nuts are there. You can use it for number of times. but the rivet cannot be used. So that the rivet component is being removed from your syllabus. Here it is being connected by nut and bolt. Okay, like that, this connections, what is the purpose of making this connection is, whatever the moment which is there in a beam, which is being transferred to the column, exactly, if 100 kilonewton moment are acting here, the same 100 kilonewton moment is being transferred by this connectors, and it transfers up to the foundation level. From the beam column up to foundation, this connection helps us to connect all the elements. The connection element or component are used in the places such as cleats. So what do you mean by cleat? I have given example. This is cleat. In top of beam, if any angle section is used, then it is known as cleat. Okay, what do you mean by gusset plate? If number of members are more, if 2 or more members are there, if 5 members are connecting at a joint, you need a plate. That plate is known as what? Gusset plate. Here you can see the gusset plate. Okay. Then brackets. So can you recollect that what is bracket? The brackets are provided at the corners between column and beam, and it is used to stiffen the component. It will not allow to bend. Connection plates. So you know that it is used. These elements are being connected such as rivets, bolt, pins and wells. So these are the different kinds of connection which are available. So how to avoid connection failure? Before designing the connection, you should know what are all the key points to take care when you are designing the connection and how to avoid the failures. Okay, what is the goal of a connection is to produce a joint which is safe, economical and simple. If you are making any connections which are the most critical part, if you understand connections, then it is very much easy for a designing any steel structure. So that it should be safe, economical and simple. The connections are the place where the workers are very much have to work in order to construct. If the two bolts are connected between only 3 or 4 mm gaps, can you make the bolt or can you tie the bolt if no minimum clear space are available? What will happen? You cannot install the bolt. If two bolts are very much close, how you can install? Or two bolts are very much near to the corner, what will happen? The member will easily break. So you can see this example. See, you can make the bolt at extreme side also, and you can connect the bolt at the lower part, that is with the centroid, along with the centroid also. What happens? There should be a right place so that two bolts are not being merged, and it should be easily available for the worker if you are providing 4 number of bolts. See, bolts are having different types of grade, similar to the steel. Steel, how many grades are available? Fe 250, Fe 415, Fe 500, Fe 550, like that. Same way, bolts are also having some grade. Bolt grade is 4.6, 5.6, 5.8, like that. Bolt grade is also available. If you are seeing any nut and bolt, you will see that all the nut and bolts are same. No, it is not like that. Each and every bolt is different by their characteristics. If you are purchasing 11.6 bolt, so the bolt grade is, if I am telling you to buy 4.6 grade bolt, 11.6 grade bolt, the price is different. Price is different in terms of, it might be in 2 times or 3 times. You should know what grade of nut and bolt you have to use. If you are using, say here you have 4 number of bolts which might be in grade 4.6. If it is too congested in a point, what you can do is you can replace that by 8.8 number of bolts, and you can provide only 2 bolt is enough. For the same connection, only 2 bolt is enough per side. How it is possible? you are increasing the grade size. If the workmanship is very much difficult, you can reframe that. You can use higher grade of bolt. You can make clearance in working or installing. Like that, whenever you are designing any connection, it should be simple. It should not be complicated. You should not provide number of bolts, 10 number of bolts cluster like a star, and you should not make like that. It should be very simple, 2 or 3 bolt, and it should be economical. You should not use higher grade of bolt when lower grade are sufficient, like that. And it should be very safe. Whenever you are designing, make sure that it does not collapse. So this is the major goal for a connection. For this, you can make number of options. Okay, connection failure is not as ductile. See, this connection will not fail majorly in ductile mode. It will be brittle. What do you mean by ductile and brittle? Ductility is if any member you are having, during the breaking point, it will elongate. It will elongate to certain 10 to 15 percentage. If this is 10 centimeter, when it is breaking, if it is a ductile material, it will break and its length will be 15 centimeter. It will be in 12 centimeter, while breaking it will be in 15 centimeter. This is known as ductile. What is the example for that? Steel. Steel is a ductile element. If you are bending the steel and if you are elongating, the steel will definitely get elongated and its size gets increased. What is brittle material? Concrete. If you are purely making a concrete beam, if it is breaking, so does it have more elongation? The concrete will not elongate and break. It will break suddenly. So it is brittle. So ductility is not there. Elongation is not there. So this is the understanding. All the connection will break in a brittle mode, not ductile. When the bolts are breaking, it will break into two pieces directly and it will shear and it will be broken into pieces. It will not elongate and it will break. So this is the idea of that. Okay. It is important that connection develop full and little extra strength of the member. Whenever you are designing a connection, if you are designing the beam for 10 kilonewton per meter and designing the column for 12 kilonewton per meter, the connection should be designed more than 12 kilonewton per meter, not less than 12. The connection should always have strength more than what? The members. Beam is a member, column is a member. So always the connection should have what? Little extra strength than the members. So the connection should have at least 15 kilonewton per meter of strength. Okay. The failure may be avoided by adopting a higher factor of safety. You should use the factor of safety as per the given code and hence it will eliminate the failure. Okay. Finally, lack of fit, resist corrosion and easy to maintain and provides reasonable appearance. So these are the requirements. These requirements it should satisfy. And if it is coming under all the category, then whatever you are designing is safe. Yes, next title is classification of connections. The structural connections are called as these types. When you are calling in terms of fasteners, they may be called as rivet, bolt and welded connection. So these three types of fastenings are available and according to fastening, the connections may be called as rivet, bolt and welding. Okay. When the connections are according to the structural purpose, it might be rigid type of connection or simple connection or it can be semi-rigid. In terms of joint resistance, two types are there. First one is bearing and friction. If it provides any frictional resistance, then it is called as friction connections and it only bears the load, then it is known as bearing connection. Okay, fabrication location, the connection might be done in shop or it might be done in field. So these are the two types of fabrication which are available, and joint location is beam column. You can connect beam and column. It can be called as beam column connection. Beam to beam connections are available and column to foundation connections are available according to the location, according to the members what you connect, that is another classification. And connection due to geometry, that is single web angle connection. I have given an example for web angle connection. If any connection is made between web and the column, which is known as the web angle connection. Single plate connection. If you are having two elements and if you want to connect that, this two element is being connected by adding a plate. So they will add a plate and then they will connect that. So you can add this single plate or you can use double plate. What do you mean by double plate is, if you are connecting two members, front side, back side, both the sides are connected by using a plate, then it is known as double plate or back to back plate, it is called like that. Then double web angle section, top and seat angle. I have given example for seat angle. Seat is provided at bottom, clip is provided at the top. So according to the geometry. So these are all according to the geometry, with or without stiffeners. Okay. Then types of force transmitted. It might be shear connector, shear and moment connection, and simply moment connection. These types of connection available. If the connection carry only moment, if the connection carry shear force and moment, then it is different type. If it carries tension and compression, like that, whatever force is being taken, according to the force, the connector is being differentiated according to the shape, according to the geometry, according to the location, fabrication, resistance, like that. The connectors can be differentiated. Every type of bolt have the Indian standards. If you are using unfinished bolt, it should compile IS 1363. If you are using precision bolt, 1364, 1364 for semi-precision, and for high strength bolt it is 1357. So according to this code book, their characteristics will be there. These are the 6 types of bolt. According to the purpose, they might differ. See, the unfinished bolts are black bolt, which are used for non-structural purpose, for temporary purpose. So they are being used. And high strength bolts are engineered bolt. So during the evolution of engineering, the strength of the members are keep on increasing. So when you are using that, when you are using high strength members, then you will be using this high strength bolts. According to the location, according to the purpose, these bolts may vary. See, these are the unfinished bolts. When you are observing, now you can observe these types of bolts. These are types which I have discussed in previous slide. This unfinished bolts are, you can see this component is known as shrank and this component is known as thread. So in certain bolts you will be having higher shrank and lower thread. So this is known as unfinished bolt, and this bolt is used for non-structural purpose. The heavy loads are not there. Just you have to fasten or just you have to connect. For this purpose you can use that. And this is the turned bolts. So this turned bolts do not need nuts. Without nut you can tighten that. So these bolts are like that. See, according to the purpose it varies. If cannot work at the other side, you cannot use bolt, yes or no? You can only tighten at the single side. So in those kind of area you can use the turned bolt. You can see the hexagon shape here. You will be having a key and by this key you can turn that. So according to your work whatever you are doing, you can use this type of bolt, and this is known as ribbed bolt. What I mean by rib is, here you can see the ribs. This is the difference. So you will be having thread and less shrank is available. What do you mean by shrank? Which is the plain area. Less shrank is available and you are having threads. So wherever you are having the members which is subjected to twist, if you are using the vehicle parts, if you want to connect vehicle parts, say for lorries will be connected with the wheel axle. You will be having two wheel and there will be an axle. You have to connect with the bolt. This wheel will be always having moment force and you will be having the transition force. If any component which is having twisting force as well as the transitional force, at these points you can use the ribbed bolt. Why? Because it have the tightness for rotation as well as the transition. So you can see the ribs here. Can you see the lines? This will not allow the member to rotate easily. If you are providing this kind of member, this will easy to rotate. So this ribs will not allow the members to rotate. So this is another type of bolt. And I have said that high strength bolt, yes or no? 4.6 bolt, 6.6. This bolt is 8.8. Can you read that? If you are looking into bolt, now you look into this numbers. In each and every bolt, in the top of the head, you will be having numbers. You just observe that. If it is written as 8.8, then this is the grade of the bolt. 8.8 grade. What do you mean by 8.8 is, I will tell you in the next slide. And by using this, you can identify the strength of the member. And this is precision bolt. This is used for highly precise works, and turned bolt are used for the similar purpose where you have high vibrations. If vibration members are being connected, see currently you can see the railway lines. If two railway plates has to be connected, railways will be subjected to vibrations. So you can use turned bolt. What do you mean by turned bolt is, here you can see the nut. Nut is not only a single nut, it is being locked by this member. So this turned bolt will give higher grip towards the vibrational force. So these are the different types of